Hi everyone, we're going to discuss our clinical UPS. For the first question, the function fx is given, has a root in the interval of -1 and 0. Select the appropriate equation for the graphical consideration to prove that a proof statement. So we need to use graphical method. So if graphical method, we need to express it in two functions. So for fx, so x plus 4x squared minus 2, we let it goes back to 0. Then we try to separate according to our option. Our answer we will be exponential function at the left hand side, and we move the function x become negative and 2 become positive. So this is one of our graphical method. Considering 4x and negative x plus 2. So look like we don't have the answer. Maybe we move back. Another option is move the negative to the left hand side. Here we have for the positive linear. So negative exponential and positive linear. So here we have our option 4. Then the equation ln x equals to 3 minus x has a root between 2 and 3. Which of the following statements are correct? So if it has a root between 2 and 3, when we substitute to the function, it's supposed to have different sign. And the intercept of fx and x-axis is the roots. So yes, it is the roots, it is the x, so have same sign will be wrong. Therefore, we only have the option 1 and 3. For Newton-Raphson formula, finding the roots for this equation is, so we need to find out what is our function. We make it to equals to 0. So we move it 1 minus 2 sine x minus x. And when we differentiate this function, differentiate 1, we get 0. Differentiate sine, we get cos positively. Differentiate negative x, we get negative 1. And then Newton-Raphson method will be Sn is not plus, it is minus function over differential function. So look at our function, differential function. So this is wrong. So which one differential function is correct? You will see that our answer is a bit different, but it's okay. Maybe we factorize it negative. You can get 2 sine x, and then here will be plus x minus 1. And for the denominator, we factorize the negative, it will be 2 cos x plus 1. So negative simplify, so here will be our fx, this is our f prime x. Here we have our option 1. Alright, so differentiate this, we'll get this, then integrate this. We know that differentiate a, we get b, and we integrate back. For the same function here, suppose we can get 2x squared over 3 minus x. So what we want to integrate here is without 2. So without 2 here, what can we alter with this equation? If we don't want the 2 here, we can factorize back the 2. With the result equation here, and we move the 2 to the right hand side. So we can get integrate x 6 minus x 3 minus x squared. It will give you divide by 2 x squared 3 minus x. Then c divided by 2, it will seem the same constant of the c. So here we have our answer. Then we're going to integrate this. So simplify first. As you can see, denominator is 1. We can simplify this. So 3x minus 1, and then this is x power of 1 over 2. When we simplify, it will be 3x power 1 minus 1 over 2. We get 1 over 2. And this one, power move up, become negative 1 over 2. And we integrate using formula power plus 1 over new power. Again, power plus 1, 1 over 2, so 1 over 2 flipped up, and plus c. So you can see, this one we can simplify. So here we have our answer. Then integrate exponential. So integrate exponential, copy the exponential, divide to the coefficient of the x, -2. Because this is not base e, we need to time with the ln base here, which is base 2. So here we have our final answer. As we can see, we need a -2 here. We don't have -2 ln 2, but how it can get ln 4? So it will be 2, move up, become 2 to the power of 2. So here it will become ln 4. So that's why we have this answer. Then integrate for this, we simplify first, integrate 5. Then when this one simplify, we get -1, it will remain in fraction. Power of 2 will be simplified to become power -2. Then integrate one by one, integrate constant, we get linear. Integrate fraction, we get ln. Then integrate this one, x will be power plus 1 over new power n plus c. So here we have this. So you don't see just fraction, then you directly ln. So fraction formula only occur for the denominator power of -1. If you x power of -1 means it is a formula of fraction. So we have this as our final answer. Then we're going to integrate cos. Integrate cos, we get sine. Don't forget its angle, which is 2. So remember, cos at left-hand side, sine at right-hand side. So integrate, we will read the symbol of opposite symbol. So therefore, integrate cos, we get positive sine. And then integrate sine, we get negative cos. And its angle is 1 plus c. So therefore we have sine 2x plus 3 cos x. Integrate trigo square. So integrate trigo square, we're going to simplify using double angle. So cos double angle will be cos 1 plus. So we have two kind of situation, which is sine square angle and cos square angle. So cos square angles using symbol cos, symbol of plus. Double up the angle becomes 6x. So over 2. Simplify some more this one. So it can equivalent to, no need to integrate, finish. It will be equivalent to 1 plus cos 6x only after we simplify the 2. So here we have our option. Then how about integrate this? So this one we can use giant function formula. So what is your giant function formula? Where we can see function power of n and it multiply with its differential function. Means this is giant function formula. How it work out? Power plus 1 over new power, that's all. So we just need to check. So this is our giant function with power. Our fx is 3x cubed minus 5. So we check, is it this one is differential? We try differentiate this, we get 9x squared. Yes, we get x squared, but we get not 2. So we just need to alter our situation of the coefficient. So coefficient 2, you no need, we take out. To get to its pattern, you need to multiply with the coefficient that we want, which is 9, so that you can get your f prime x, your differential function at the side here. When you multiply 9, we didn't alter the question. We need to divide back the question so that value will be equivalent back. Therefore, this is our fx, this is our f prime x. We are in the pattern. This formula will bring you power plus 1 over new power. So power 5 over 5 plus c. So you conclude out 9 times 5 will give you 45. So that's all. And when we want to integrate x sine x. So x sine x, it is two functions multiplied together. As we can see, this is polynomial, this is trigo. Trigo sine x is very simple already. When we multiply with another function, means this is integration by part. So formula u dv equals to uv minus integrate v du. U will be selected as log back, so polynomial function will given priority. dv will be the rest of the integral, which is sine x dx. So differentiate u, we will get 1 with respect to x. So du will get dx. Integrate both sides, here we'll get v. Integrate sine, we'll get negative cos x. So when we put it in the formula, here we have u v minus integrate v du which is dx. So simplify, negative negative become positive, and then integrate cos, we get sine x plus c. So we have negative x cos x plus sine x plus c. Here we have. Okay, so for this question, we're going to solve 1 over 2x, x minus 2 dx. So we can see this is a fraction, and we cannot use formula. So this question, we're going to solve by partial fraction. So first of all, we need to express this fraction in partial form. We're going to split according the fraction. So it will be 2x, and then x minus 2. So linear up here is constant. Then we're going to get same to the denominator. Then we're going to let x equals to 0 and x equals to 2 so that we can find out the AB. When we have x equals to 0, we have negative 2a. So a is negative 1 over 2. When x equals to 0, x equals to 2, you get a 4b. So b will be 1 over 4. Therefore, this integration will be integrate for a will be negative 1 over 2, 2 become 4x plus 1 over 4 x minus 2 dx. So for integrate this, we factorize 1 negative 1 over 4, integrate 1 over x, we get ln x. This is also the fraction, so ln x minus 2 plus c. So we have a look here, which one is our option? Last year, our answer is at option 4. Which of the following are true? So integrate ln x is integration by part. Yes, we don't have the formula for integrate ln. And this one can be used by partial fraction. Yes. And we can see this one x squared with this can be using substitution. So all of these are true. And when we want to integrate it, sine times cos. So we can use our giant function. This is fx is sine, f prime x is cos, giant function, integrate fx, f prime x. So your function will be power plus 1 over new power plus c. So this one, our function plus 1 means sine square will be over 2, upper limit k, lower limit 0. And we substitute the limit, it will be sine square k over 2 minus sine square 0 over 2. Sine square 0 will give you 0. So here we have our sine square k over 2. One more thing we can do is sine square can change to identity, which is 1 minus cos square k over 2. So 1 over 2 is our constant. So here we have our option. So we can see this is our, they ask us which statement is not. So this is our answer. And then this one also our answer. And if you double up the angle, it can give you 1 over 4. So if you change cos square become double angle, it will become 1 plus cos 2k over 2. So here we have 1 over 2 minus 1 over 2, then minus 1 over 4 cos 2k. 1 over 2 with 1 over 2, this is 1 over 4. Alright, so that is our final. So this is not our option of our solution. Next, we're going to integrate this. So 5e negative 5x, integrate for negative 1 over 5 until 1 dx. So this integration will give you e negative 5x over the coefficient negative 5, simplify. And when we substitute your limit, it will give you negative e negative 5 minus negative e negative become positive. So negative become positive e1 minus e negative 5. So here we have our option 2. Right, continue for this. So when you want to integrate this, we will integrate 4pq for fx dx minus integrate pq for gx dx. So for fx, integrate p and q is, so p and q is inverse, which means that the limit is opposite. It will go into negative our function, so it becomes positive. This one integrate p to q for gx, which is 5. So 20 minus 5, it gives us 15. Then, how to decrease the accuracy of approximation of defined integral using trapezoidal rule? Decrease the accuracy. So when we're using trapezoidal rule, the more trapezium we use, our area will be more accurate. So they want to decrease it, means you need to increase the number of sub. So when you increase, will increase the subinterval, you increase the accuracy. So number 1 is wrong. Decrease the value of the width. Decrease the number. Okay, when you get less trapezium, it's getting less. Increase the value of the width. So we want to increase or decrease of value of the width. Width is this. So when you're getting more trapezium, means your width will go into less. So decrease the value of width, your accuracy will increase. Increase the value of width means you use bigger trapezium. Make sure this is one trapezium, this is one trapezium, your accuracy will going down. So therefore we have option 3 and 4. So find the y of the trapezoidal rule for the defined integral, means the y is your h. Your height of the trapezium. So h will be b minus a over 2, upper limit minus lower limit with 5 ordinates. So you just imagine 5 ordinates, how many trapezium? 1 ordinates, 2 ordinates, 3 ordinates, 4 ordinates, 5 ordinates. So inside here we have 1 trapezium, 2 trapezium, 3 trapezium, and 4 trapezium. So 0.5 divided by 4, it will give equals to 0.125. So here we have. So for the last questions, so use the trapezoidal formula to find out the table. They already given here. This is your x1, x2, x3. They already sum out. So I want to find the h. H, it will be the interval. It is 0.5 over 2. Then y1 plus y3, 2.0318 times plus 2 times the total here is 1. So we just make sure we put in the correct formula with the correct value, and we press calculator and correct it to 3 decimal place. We have 0.07955. So 3 decimal place will be 1.008. So that's all for this. Thank you for watching.